Hi everyone, I'm Padripa Kapujita. I'm currently pursuing my bachelor's in the stream of Computer Science and Engineering at SR University. Coming to our capstone project, feature extraction and classification of languages using deep learning models. Before discussing our project in detail, I want to introduce my teammates.
I'm Sri Rashmi. I'm pursuing my bachelor's in computer science at SR University.
Hello, I am Ishwantini, currently pursuing my BTech at SR University in the stream of Computer Science and Engineering. Thank you.
Hello everyone, my name is Rohit and I am from Computer Science Engineering.
Coming to our project, feature extraction and classification of languages using deep learning models. We done this project under the guidance of K. Shivakumar sir. And coming to problem identification, lung diseases pose significant health challenges worldwide, necessitating early and accurate diagnosis for effective treatment and management. These diagnostic challenges can benefit from advanced image analysis techniques. And coming to objective, we want to develop an reliable, predictable model for detection and diagnosis of lung disease using X-ray images such as pneumonia and tuberculosis. Coming to existing methods, these are some of the existing methods of lung disease prediction. And coming to literature survey, here we have taken 10 literature recent papers of research 10 research papers on lung disease. These are, and coming to proposed solution, here we are planning to predict lung disease such as pneumonia and tuberculosis using deep learning models VGG16, VGG19 and NSTED 121 model. And this is the model here: input data set and deep learning model, that is CNN model, and image processing lung disease prediction model. These are the architecture of VGG16, VGG19 and NSTED 121, these models which we are using in this project. And coming to data set, we have collected the data set from the Kaggle of grayscale chest X-ray images collected from various medical institutions. And coming to its the labels are of normal, pneumonia, and tuberculosis. Here, the normal folder consists of all the X-ray images of normal, and pneumonia folder consists of all the X-ray images which affected by pneumonia, and tuberculosis folder consists of all tuberculosis images which affected. And coming to implementation, this is the implementation of our project. Coming to code, here we have developed the code using three models. This is the model VGG16. Here we are importing all the necessary libraries, and here resizing all the images to this 256 to 256, and importing the VGG16 model with ImageNet weights and exclude the top layers, and here creating a model. And here fitting the model. Here we are running this whole model 10 times, that means we are given approaches has 10. We are saving the model, and this code is for plotting the graph of training and validation loss. This is the graph, and this code is for plotting the training and validation accuracy. You can see the accuracy of using VGG16. And here we are predicting the images by giving the path of the image. This is the path of the image. This is the image from the normal folder. So here the output is displayed as 0. That means it is from first folder, that is normal folder. And here when I am taking the image from a pneumonia folder, it displays as 1 because it is taken from second folder, that is pneumonia folder. And here when I am taking the image from tuberculosis folder, it displays as 2, that means from third folder. Yes. Coming to the accuracy, when we are used VGG16, we got the total training accuracy has 0.94, that means 94%, and the total testing accuracy is 0.93, that means 93%. And here finally we have done the confusion matrix. In the same way, this code is with VGG19 model. Same we have taken here 10 approaches, and these are the same model predictions. And this is the graph for training and validation loss, and this is the graph for train and validation accuracy. Here by using VGG19, here we got the total training accuracy has 0.96, that means 96%, and total testing accuracy has 0.95, that means 95.96%. And this is the confusion matrix using VGG19 model. Now coming to DenseNet model, here same way we have taken the code, and here also we have taken the 10 approaches, and this is also the prediction of the model, predicted as 0 and 1 when we are taken from pneumonia, and when we are taken from tuberculosis it's shown as 2. This is the graph of training and validation loss, and this is the graph of training and validation accuracy. And coming to accuracy, when we are using DenseNet model, the total training accuracy is 0.97, that means 97%, and the total testing accuracy is 0.93, that means 93%. And this is the confusion matrix of DenseNet model. And here you can see the F1 score, recall score, and precision score. Now coming to the user interface, and this is the code for user interface. Here I have done the code on Visual Studio Code. Now we need to run it. I have taken the 3 conditions, that is pneumonia, normal, and tuberculosis. Yeah. Now this is the link of user interface. This is the user interface, front end of user interface. Now here we need to choose the image which we want to upload, and when we want to see the output we need to click on predict. So now I am uploading the image. Uploading image from the normal folder. So you can see that there are three different folders. One is of normal, pneumonia, and tuberculosis. I am uploading image from normal. So I need to click on predict. It is predicted as normal. Now I am uploading the image from pneumonia folder. When I click on predict, it predicted as pneumonia. Now I am uploading image from tuberculosis. Predicting, and it is predicted as tuberculosis. This is the user interface of our project. And coming to PPT, this is the input data tools. We are used that Google Colab for writing the code, implementing the code, and Visual Studio Code for implementing the user interface. And the technology stack is Python, Flask, TensorFlow, and Keras, and all the models which are used VG16, 19, and DenseNet 121, and OpenCV, HTML, and CSS for web interface. And the process we have already seen. And coming to results, during the training process, the DenseNet 121 model seems to perform better than the rest of all the other, with 97.39% of training accuracy and 93.72% of testing accuracy. Here, this is the comparison table among the three models which we have used: VGG16, VGG19, and Density 121. You can see the recall, precision, F1 score, and accuracy comparison among all these models. These are the graphs of training and validation accuracy, and these are the graphs of training and validation loss. These are user interface images. Coming to conclusion, here the conclusion is the output of this project is a reliable model for detecting of lung disease and developing a web app for lab technicians that holds great promise by providing a user-friendly and effective tool for lung disease diagnosis such as pneumonia and tuberculosis. And coming to future scope, this model can be trained on diverse data sets. That means we can train on different types of data sets also, and there is a potential for integrating the CNN model into healthcare system and making it available for use in clinics and remote healthcare settings, thus improving access to diagnosis. And the project could extend its impact by incorporating educational elements, raising awareness among lung disease, and providing insights into the significance of early detection. Thank you. This is our project on feature extraction and classification of lung disease using deep learning models. Thank you.